In this lesson on tilting or rotating, we're going to look at two situations. One is where a rod is placed upon supports and starts to tilt, or one where a rod is hanging by two strings or wires and is about to rotate. So in this first example here, we've got a rod on two supports A and B, and we've got those reaction forces at A and B called R1 and R2. If you have a look at the left-hand side of the rod, what we're suggesting is we're going to be applying a downward force P, which is going to force the rod or plank to rotate or tilt. So it's going to rotate about pivot A. So that's going to head downwards. This is going to want to come upwards. So in actual fact, the plank is going to leave the support at B. And as it starts to leave the support at B, then R2 tends to 0. And the phrase we use when it's about to leave one of the pivots is it's on the point of tilting. Okay, so R2 will reach 0 when the rod is tilts or on the point of tilting about A. So here's the example. This time we've got the force here on the right hand side, 60 newtons, so that's going to push down. The rod is going to then pivot about point B, and therefore the rod is going to raise upwards off the support at A. So what we should see is that R1 is going to tend to 0. So as it's on the point of tilting about B, the rod lifts off support A, and therefore R1 equals 0. So now we remove R1, and that's the situation that we have left. And if we take moments about B, clockwise moment is going to be given to us by the 60 Newton force, so it's 60 newtons times 2 meters. And the anti-clockwise moment is given to us by the weight of the rod times by 1 meter. And then those two things are equal to each other. No, it's just on the point of tilting. So in actual fact, there is still equilibrium. It's just in equilibrium, only just. And when it's only just in equilibrium, we can still use the fact that the clockwise moments equal the anti-clockwise moments. So we end up with 120 equals mg, and that gives us a mass of 12.2 kilograms. In our second situation, we've got a rod which is hanging by two wires. And as we've seen in a previous moments video, those two wires give rise to two tensions, which are called T1 and T2. And if we apply a downward force F here at A, what you will see is the rod rotate about point C. So this end will raise upwards. And when this end raises upwards, then this tension in the string becomes 0. So the rod's on the point of rotating about C, and therefore the cable or wire at D goes slack, and therefore T2 equals 0. And that means we're left with a force diagram that looks like that. So here is our example, non-uniform rod, length 10 meters, weight 40 newtons, and we've got our two cables. And a weight of 25 newtons is going to be hung from A, so it's going to be hung at this end. So what we're going to see is going to rotate about that point. That will rise upwards, which means the tension here in this wire will become 0. So we've got the weight, we've got the tension T1, the tension T2, but then when we apply the 25 Newton force, It's going to rotate about point C, and the cable at D goes slack. So T2 equals 0, and that's our force diagram. We now put a distance of D meters between the 40 newtons and C, and let's see if we can calculate D from there. So we're going to take moments about point C. The clockwise moment given by the 40 Newton force is 40 newtons times D meters, that's 40 D Newton meters. And the anti-clockwise moment is given by the 25 Newton force, 25 times 3, that's 75 Newton meters. The two quantities are equal to each other, and therefore D equals 1.875 meters. So the total distance from A is 4.875 meters. So if you want to turn to exercise 4E, have a go at the questions there, and good luck with those.